Hello everyone, Mr. Minnick's my name, math is my game. This is the fourth time I've taught this lesson today, not that you care. So I'm going to do my best to make sure I cover all the points about everything. For those who are watching this back at home, shout out to all of you. You're awesome. Shout out to the future Mr. Minnick also. Shout out to Stephen Miller and the Stephen Miller Band for having one of the greatest classic rock songs ever. We're going to start off by saying let a sub n and a sub n minus 1 and a sub n minus 2 dot 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 a sub 1 a sub 0 be any real number. In mathematics, when we define something, we define it because it's important. My wife and I have a lot of communication issues because we define words differently. And so I came up with this idea to make a Google Doc. And we both put down our definition of a word. So when she says, do you want me to bring my purse into the restaurant? I understand that she's saying, I have lots of ones, I can leave the tip if you'd like me to. So people communicate differently, and in math, we try to make things as clear as we can. So this green statement essentially says all the coefficients of a polynomial have to be real numbers. Okay. The other thing we're going to say then is also, we're going to say and n can be any whole number. What n is going to be is a power, an exponent, and it's actually got a special name. And n can be any whole number. So when we do all that, we'll say then a polynomial function, then a polynomial function, then a polynomial function. I feel like the guy from Khan Academy. He says everything twice. Then a polynomial function p of x is defined in the following manner. I hope you brought your armor with you. I don't know what it is in life about armor. I know when I ride motorcycles and ATVs, if I have full gloves, jacket, boots, I ride really dumb. I do wheelies, stoppies, go as fast as I can go without putting other people in danger. So anyway, polynomial function is defined in this way. P of x is equal to a sub n. People are scared of this. A sub n x to the n plus a sub n, this is a little n minus 1, x to the n minus 1, plus a sub n minus 2, x to the n minus 2 plus that continues. We don't know how long it continues, but it continues. We did the first three terms. We're going to do the last three. The last three terms are going to be plus a sub 2 x squared plus a sub 1 x. If this were junior varsity math, which it's not, I put a 1 here, but this is varsity math, so we don't need that 1 there. And then on the end, we have plus a sub 0. That shows up in just about every single textbook ever written on the subject of algebra. That's what a polynomial is defined as. The good news is you don't need to have that memorized. I might ask you to write it out on an upcoming quiz. I probably will, as a matter of fact. What's the definition of a polynomial? And there it is. Just as important is that what's in that manila box are the restrictions. Remember, the coefficients have to be real numbers. The exponents have to be whole numbers. So far, so good. Okay. Well, we're going to pick people out of the crowd. We're going to pick this a sub 0 out, and we're going to talk about it. Anybody know what its name is? It's a sub 0. It starts with a C, and it ends with a T. Not coefficient. It's a constant. Good. Some people will go so far as to say that it's the constant term, but it is a constant. Now, one thing I omitted, because this is varsity math, I could have written times x to the 0 power, but I won't because I don't need to. But what you do need to be aware of is that the degree of that particular term is 0. That particular term has a degree, which we'll find out means exponent. It has a degree of 0. And I'm sorry for everybody watching this back if you just heard me breathe through my nose. I'm having a hard time breathing. Air's a little dry. So this next term right here, this term, the whole thing, we call it a term. And in chapter 2, we skipped over this. It starts with an L, the word I'm looking for. L ends with an R. So when we study lines, linear. It's called a linear term. Bless you. Welcome. So then we got this other one here that's got a degree of 2, and it's called our quadratic term. Our quadratic term. We could go on all day, and we're actually going to make a table. Going to make a table here in a minute. So the second term, thank goodness we don't need to worry about the second term or the third term. But this first term, we want to talk about that for a minute. Collectively, this whole thing here, that's our first term. A sub n is the leading coefficient. A sub n is called the leading coefficient. Sometime this week I might show you a video that says scream and shout and graph it all out. And they're going to talk about an LC, and that's the leading coefficient. Okay, we'll abbreviate that LC. So that's a sub n, and then finally this exponent up here, n is the degree. When somebody asks you, what's the degree of this polynomial? It's the biggest exponent that shows up. It's the exponent that shows up on the term that's written first. Okay, so to be clear, n is the largest. N is the largest exponent in a polynomial. And I know it's confusing because I said the constant has a degree of 0. That particular term does. But overall, this whole polynomial, its degree is the biggest exponent that we see. The whole polynomial, its degree is the biggest exponent that we see. So there's kind of a subliminal message here that they're sending you. They're telepathically sending you a message in this definition. Look at the exponent of the first term. It's n, right? That's a whole number. You with me? Something like 9, 10, 15, who knows? But look at the next term. How big's the exponent on the next term? N minus 1. So is it bigger or smaller? Smaller. And then the next one? Minus 2, so it's smaller still. And then the next one gets smaller and smaller and smaller. Does that all make sense? Good. That segues perfectly into the next thing then. So the next thing then is what we call a form that you don't want the abbreviation to. I really shouldn't say that. Standard form. Standard form. Standard form of a polynomial just means that like terms are combined. Like terms are combined. If there are like terms, they are combined. Like terms are combined. Standard form also means that terms are written in descending, that's largest to smallest, descending order by degree. Descending order by degree. Terms are written in descending order by degree. That's the second time I did it. I just breathed into the microphone again. I got to quit doing that. One side note about this is before naming a polynomial, you should put them in this form before naming them. Okay, so use this form prior to naming them, prior to naming a polynomial, you should try to get them in this form first and then give them a name. I used an example earlier today. I said it's kind of like naming your unborn child Zeus. And your unborn child ends up being like 4'6", right? Probably not the best name for somebody that's 4'6" would be Zeus. Just saying. So far, so good. All right. So the next item up for bids then is naming them. Naming them. Polynomials have a first name, and a last name. So every time I think of this, I always think of the little kindergarten student that said to the teacher, "Teacher, my mommy's having babies, twins." The teacher said, "Oh, really?" And the kindergartner said, "Yeah. And you know, they're going to be Chinese." "What do you mean they're going to be Chinese?" "Well, they told us that 2 out of 3 children born in America is Chinese." "And I'm not, so they're going to be Chinese." Anyways, the whole reason I bring up the Chinese, in China, and I'm not trying to make fun of China, but in China, the last name Chang is about as common as the last name Miller, Smith, or Jones here in the States, right? So what I'm saying is a generic name in polynomials is to call it a polynomial. But when we call them by their first name, last name, the first name is how many terms? I'm sorry, not how many terms. It's the name by degree, I'm sorry. It's the name by degree. And the last name is the name by the number of terms. The name by the number of terms. So when we refer to some polynomial, we might say what we've got is a quadratic binomial. We might say we have a quadratic binomial. What a quadratic binomial might look like is this: 6,000 x squared minus 41. 2 terms. The biggest exponent is 2. Even though that's a binomial, it is still a polynomial. So we don't always have to give it a last name. You know, some people are just referred to by their first name. Some people are just referred to by their last name. Polynomials are the same thing. You could say it's quadratic. You could say it's a binomial. You're not wrong either way. You could call me Matthew. You could call me Minnick. You're not wrong either way. You're referring to it. It's just a different way of referring to it. Does that make sense? Okay. So there's this wicked huge table. Man, look at this. Big table. I wish Luke Porter were here. I'm going to give a shout out to Luke Porter. I like him. So in the first column, we're going to look at some polynomials. And then after we look at some polynomials, we're going to give them a name by degree. Name by degree. And then in the last wide column, we're going to give it a name by the number of terms. Name by the number of terms that it has. So in the little narrow column, the first narrow column is going to be the degree. The degree. What's the biggest exponent that shows up? Oh my, almost, I'm tripping. That would have been bad. Probably would have split my wig. And then the last narrow column is going to be the number of terms. How many terms this thing has. So we're going to look at a few of these. We're going to look at many polynomials. So the first one we're going to look at is going to have my favorite number in the whole wide world, 3. It's a great number. It's the best number ever. It's prime. Answers a lot of questions about life. Anyway, the degree is the exponent that's on the variable. And you're saying, well, there's no variable. You're right, there's no variable. But there is. And the exponent on that variable is How much? It's 0. So the degree here is 0. Since the degree is 0, we have a name for this. If we go back to the first page, you might recall what it is. When the degree is 0, that particular term is called it's like our a sub 0, right? What's that called? Constant. Okay, so that's our constant. So that's the name. That's the name by degree, constant. Terms are separated by addition or subtraction. There's only one thing there. There's one term. And this reminds me of Epstein-Barr. I never got this growing up because I didn't kiss people. Well, I didn't kiss. Well, never mind. I don't want to talk about that. Mono. I get mono now. It's called Epstein-Barr when you're an adult. I get it from being around all y'all. Anyway, mono. It's a monomial. Monomial. When there's one term, it's a monomial. Some people actually call a unicycle a monocycle. Anyway. So the next one we'll look at is going to be x plus 5. The degree is the biggest exponent that shows up. The largest exponent that shows up, the exponent on this variable right here, what's that exponent? That exponent's not a 0, that one's a 1. So the degree here is 1. If the degree is 1, we have a special L word that we call this. Linear, good. Terms are separated by addition. So there's an x, there's a 5. So there's 2 terms here, right? So this reminds me of why bicycles fall over. You know why bicycles fall over? They're too tired. Good. I used to know so many puns. Now, not so much. Not so much. I was going to write a play about them, a theatrical production about them, but anyway, it's another story. So let's try x squared plus 4x plus 4. What's the degree on that one? 2. The name, since it's a second degree, it's a quadratic. Good. This one's actually a special kind of quadratic. So it's a quadratic. It has how many terms? 3. And if it's got 3 terms, what do we call it? A trinomial. Boy, you guys are good. Awesome. Awesome. Good. I really wish Luke Porter were here right now. So there's going to be 3, there's going to be 4, there's going to be 5, there's going to be 6. This reminds me of dancing. I'm not a dancer, by the way. Never have, never will. It's against my religion, kind of. So we're going to go all the way up to there in the table, I think. Maybe. So let's keep on trucking. Let's go with 6x cubed minus 4x squared plus 3x plus 1. So the degree there obviously is 3. The number of terms there I think is pretty clear. It's 4. But the names here, this is probably going to be where we hit our first roadblock. I have a feeling that about half of the world's population isn't going to be able to answer the rest of these questions the right way. What do we call it when the degree's 3? Cubic, nice. The degree 3 means it's cubic. That's spelled C-U-B-I-C. You know how I like spelling. C-U-B-I-C. Now, if a polynomial has any more than 3 terms, you know what we say it is? Chang. We just use a generic name. Any more than 3, and we just say it's a polynomial. Just say it's a polynomial. Okay? You could say it's a polynomial with 4 terms, but any more than 3 terms, and when you're naming it by how many terms it has, just say poly, because the prefix poly means many, right? Okay. Well, let's keep on going. X to the 4th. Degrees 4. Anybody remember the name here? Every time I mix up gas for my chainsaw, I always use a quart bottle, and I put 1 ounce of oil in it, and I mix it at 32 to 1, because there's 4 quarts in a gallon. Quartic. Okay. So if we went with x to the 5th, 5 is If this reminds him of a Bob Dylan song, Quintic. 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 So here's a moment I've been waiting for. Luke thought he had it figured out. He said, Mr. Minnick, 7, I know what it is. So what is it? He said 7 is septic. And I said, well, if that's the case, that would really stink. It's not. It's not. Any higher than 6, any higher than 5, and we just say nth degree. We just say nth degree. Okay. So if it's 6th degree, we say 6th degree. If the degree 7, we say 7th degree. There's no name because 6 would have to be sextic, 7 would be septic, and that would stink. 8 would be octic, and 9 would be nonic, and then it just gets weird. So, how do we feel about the polynomial names? Got him? Cool. This is going pretty well. We should be able to finish with some time left, I think. I hope. I just hope I don't rush through this because, like I said, this is the 4th time today that I've gone through this lesson. So, I'm on autopilot. So, let's go with an example. Let's name and write in standard form. We'll just do 2 of them. Number A, number B. Let's go with 18x minus 3 times a group of 6x plus 5 plus x squared. And let's go with 37 minus 4x minus 15 plus 18x to the 3rd plus 7x squared. So when we put these things in standard form, we got to do that before we name them. And in our first one, we probably ought to use the distributive property here. So this is going to be 18x minus 18x. Then what? Minus 15, and then plus x squared. So we're still not in standard form. In standard form, we want to write the term with the biggest exponent first. X squared is going to go first. Nice, good. So we're going to have x squared minus 15. The 18x's cancel, don't they? Huh. So now we can name it. Now we can name it. What are we going to call it? It is a binomial because there's 2 terms. That's its last name. It's a quadratic. Nice, good. So it's a quadratic binomial. Number B, is there any like terms? Are there any like terms in number B? 37 and the 15, right? Okay, so let's get our term with the biggest exponent going first. So what's our first term going to be? 18x cubed, nice, 18x cubed, and then plus 7x squared, and then minus 4x, and lastly 22, and it's plus, right? Cool. So there's lots of terms. There's 4 terms, so it's not a quadrinomial. It's got 4 terms, so it's a polynomial. Polynomial. And it's what kind? Cubic. Good. How do you feel about being able to name these? Okay. Now you know what's coming up in a couple weeks' time in this class. Midterms. I'm going to show you a midterm question that's tricky, and I hope nobody misses it. Midterm question. It is tricky. It says identify the cubic polynomial out of these 4 choices, number A, number B, number C, and number D. We'll go with 3x squared plus 3x plus 3. We'll go with 11x to the 4th plus 10x to the 3rd plus 5x squared plus 2x plus 1. And then we'll go with 33,333 x to the fourth plus 52 x plus 5, and then we'll go with 7 pi x to the third. So people aren't bad at math because they can't math. They're bad at math because they don't get language. That's why people seem, I don't like to use the D word, but that's why people sometimes in the real world seem dumb. I really hate to use the word dumb, but it's when somebody doesn't know something, I think 9 times out of 10, it's not that they don't know it, it's they don't understand it because there's a barrier in the language. You look at this and you're seeing the word polynomial, and what are you thinking? How many terms? You're thinking, well, we just learned if it's got more than 3 terms, it's a polynomial. So you're thinking, well, it's got to be B, right? But that's a Chang. They're all polynomials. It's not B. So you got to know what cubic means. You look at cubic and you think, well, 3. So it's number A because it's got 3 terms and it's got a 3 in every single term. But it's not A. Cubic doesn't just mean 3. Cubic means that what's 3? The exponent is 3. So you're looking at D and you're scratching your head and you're like, well, wait a minute, 7 pi. Pi is real. Our coefficients can be real. The degree is 3. The right answer here is D. The one on your midterm is going to be tricky like that. It's not going to have the same numbers, but it is going to be a polynomial just like that. Does that make sense? Everybody feel okay about that? Good. Well, there is an exam question that I give to my seniors. Have a few seniors taking a final in Algebra 2, and this is what I give to my seniors. Senior exam question for their final. I say write a linear trinomial. Write me a linear trinomial. What do you think of that question? Let's think about this. Trinomial, it's got to have 3 terms. Boom, boom, boom. Separated with operators, pluses or minuses. It doesn't matter which is which. Maybe we'll make them both minus. Linear, the degree's got to be 1. So maybe it's negative 16x, but it's 16x to the first power, right? Okay, what's the next term going to look like? Minus 0. Okay. And then what? Minus 0 again. But if we combine like terms, we've got a linear monomial. Because you should make it in standard form before you name it, right? Okay. So maybe it's negative 16x plus 1. What's the deal with this one? Anybody see what's going on? You can't do it. It's not possible. Trick question. Trick question. It's not possible. It's impossible to come up with a trinomial that's linear, right? Can't do it. It's not just like that, but the one on the senior final is a lot like that. So, all right. Well, I feel pretty good about everything. The last thing we need to talk about reminds me of Egypt. I don't know if anybody's ever gone to Egypt. One day I'll go, and I'm going to see the pyramids. And I have a pretty good theory about how the pyramids were built. It's changed over the years. I used to believe that the ancient aliens built the pyramids, but my beliefs have changed in the last 3 months on the matter. I better not say what I believe. But anyway, so this last thing deals with polynomials and how they behave. Now, I think back to when I was in 3rd grade, I used to get a behavior grade. Not only would I get a grade for class, but I got a grade for how I was acting. And I'll be honest with you, my behavior grades were bad. Like I got U's, unsatisfactory, all the time. Anyway, End behavior, what happens with a polynomial on the ends. We know polynomials look, they do this. Whoop. So sometimes on the end, they're heading upward and sometimes they're heading downward. So here's what can happen. They could be going up and up. I call that up, up. They could be going down and down. I call that down, down. And they can go down on the left and up on the right. I call that down and up. And they can go up on the left and dog on the right. I call that up dog, just like what I got on my shirt last period, or fourth period. I was cooking hot dogs and I got up dog all over my shirt. I hope it comes out. So you might think to yourself, well, what's going on in the middle of this polynomial? Well, it doesn't matter. We really don't care. It's just what's happening on the ends. We don't care what happens in the middle. It's probably going to look something like that in the middle, okay? Might look something like that, might look something like that. Who knows? We don't care. It's just on the ends. That's why it's called end behavior. And I got to be frank with you. This concept, for those who pay attention, for those who get it, they get it. Those who don't, they're clueless. They're like, oh, what just happened? I don't know. I can't get this. It's a really tough concept to get. The end behavior is a result of the first term telling us two things. The first term tells us our leading coefficient, whether that thing is positive or negative. Whether the leading coefficient is positive or negative. The other thing that the first term tells us is our degree. And with the degree, we care about the degree being either odd or even. The degree being either odd or even. So if the graph is heading up, on the right, our leading coefficient's positive. If the graph goes up on the right, our leading coefficient's positive. You know what I've said before that I'll say again? There's two kinds of people in the world. Those who can make inferences from incomplete information. So if the leading coefficient is negative, the graph is heading down on the right, right? So the deal is the leading coefficient tells us what happens on the right side of the graph. The leading coefficient tells us what happens on the right side of the graph. The degree reminds me of a Naughty by Nature song from the 90s. Naughty by Nature had this song that started with the letter O, and then it had two consonants right after that. If the degree is odd, the graph's going to do opposite things on the ends. If the degree is odd, the graph's going to do opposite things on the ends. So if the degree is odd, it's going to be going down on the left and up on the right. If the degree is odd, it's going to be going up on the left and dog on the right. It's going to have end behavior of up dog. I can't believe nobody's bid all day. Well, one person did. One person asked me, they said, what's up, dog? Oh, not much. So anyway, what's the other case of the degree then? The degree here is what? The degree, if it's not odd, it's even? Even? All right. Do we think we're ready to try one of these? So you got to ask yourself two things. Self, is the leading coefficient positive or negative? Self, is the degree odd or even? And then it's going to fit into one of these four scenarios. So here we go. Last one. Example. Describe the end behavior of each. So number A, y equals x plus 5. Number B, y equals 2 minus 5x squared. Number C, f of x equals 14 plus x minus 2x cubed. Last one, number D, g of x equals negative 8x to the 7th power. No, to the 7th power. So let's look at the first one. What's the leading coefficient? Positive or negative? Leading coefficient's positive, right? Okay. So that means that the end behavior is going which way on which side? Up on the right. Up on the right. The degree, what's the degree? Odd or even? The degree's odd. When the degree's odd, that means it's going to do, the end behavior is going to be the opposite thing on the other side. So what's the end behavior of this one? Down and up. Down and up. Okay, so this is down and up end behavior. If you think about number A, if you were to graph it, it's a line. And what's that line look like when you graph it? Like that? What's it doing? Down on the left, up on the right. That make sense? Okay. Let's look at number B. You got to be careful on number B. What's our leading coefficient on B? It's not 2. Our first term is the one with the biggest exponent. This is our first term. So our leading coefficient is negative. So this one's going to be doing what on the what? Down on the right. The leading coefficient tells you what happens on the right all the time. So the degree, what's the degree on this one? The degree is 2, which is even. So this one's going to be what end behavior? Same on both ends, so it's going to be down and down. Down and dirty. Anybody think they got number C figured out? Or number D? So C, we're just looking at that, right? Negative, so it's going to be going dog on the right. And it's odd degree, so it's going to be going up on the left, right? So it's up dog. And the last one is also up dog. I'd like to take a minute and give a shout out to anybody in YouTube watching. Please like and subscribe. I've never said that. That's the first time ever I've said like and subscribe. I hope this has been educational. I'd like to give a shout out to my 7th period class for doing pretty good today. Anybody have anything they'd like to say to the YouTube world? I'd like to, what's that? Thanks, Urban Meyer. That's funny. I'd like to give a shout out to National Microphone Day coming up in a week. 1, 2. 1, 2. See you.